Welcome back. Today we're going to be talking about graphing proportional relationships. Our content objective is students will be able to graph proportional relationships. Language objective is students will be able to read unit rate answers from a graph. And why am I learning this? Well, it's important for many real-life problems like finding the cost per lunch. First, it's important to note that proportional relationships have a certain equation, and it's in this particular form, y equals kx, where of course k stands for the constant of proportionality. So some examples might be y equals 7x, y equals 4 over 1x, y equals 2/3 x, y equals 5.2x, c equals pi d, or feet equals 1/3 yards. So these are all examples of a proportional relationship because you'll notice that we have a k and an x in all of these examples. And then some examples that are not in the form of y equals kx might be y equals 7x plus 3, y equals x minus 2, y equals 2/3 x minus 5, y equals 5.2x plus 7. These are all examples of equations that are not proportional relationship. So what does this equation have in comparison to this? Well, it's the constant, okay? What this constant ends up doing is it doesn't allow the graph to go through the origin, 0, 0. Okay, all of these will go through the origin. However, with this, it will shift it, which would mean it doesn't go through the origin. So for example number 1, it says state whether the equation represents a proportional relationship. Why? I'm going to say no. How come? Because it's not in the form of y equals kx, because of this constant. And again, because of this constant, it's not going to allow the graph to go through the origin 0, 0. How about number 2? The answer is yes, because it's in the form of y equals kx. So I can even prove it to you. If I made x a 0, then 2.3 times 0 is 0. This is proof that it does go through the origin. Number 3, I'm going to say yes again because it's in the form of y equals kx. And once again, I can prove to you if I made x is 0, then 2/3 times 0 would make y also a 0. How about number 4? The answer is no, because it's not in the form of y equals kx because of this constant here. And again, I can prove it to you. If I made this x as 0, I would say 5 times 0 is 0 minus 7 is negative 7, which means it does not go through the origin, which means it's not a proportional relationship. So here for number 5, it says graph the proportional relationship. So here, one thing that I do want to mention just so that I can prep you for future problems is I want you to note that this denominator is a 1. You're going to find that whenever we're posed with a constant proportionality that's not a whole number, that the best thing to do is to pick multiples of the denominator, which in this case is a 1. So first, I'm actually going to start with a 0 because multiplying by 0 is a very simple number to multiply by. So here, y is going to equal 3 times x, which I'm making a 0. So what is y? Y equals 3 times 0, so that's going to be 0. So this proves it's going to go through the origin, which is a good sign. Now, next number, I'm going to go to 1. So y is going to equal 3 times x, which I made a 1. So 3 times 1 is 3. So my ordered pair is 1, 3. Next number would be 2. So I'm going to go ahead and do y equals 3 times x, which I'm making a 2. So 3 times 2 is 6. So y is a 6. So I'm going to go over 2 and up 6. Next multiple of 1 would be 3. So again, I'm going to go ahead and do y equals 3 times x, which I'm making a 3. So 3 times 3 is 9. So we're going to go over 3, up 9, and there is my graph. So you should expect something that's linear and it goes through the origin, and I see both of those things, so it looks good. Okay, so now number 6. Remember, I told you from the previous one, whenever you're given a fraction, it's going to be a good idea to use multiples of the denominator. So real quick, in this last one, our denominator was 1, so I picked multiples of 1. 0, 1, 2, 3. Now with this one here, my denominator is a 4. So what am I going to pick? I'm going to pick First 0, because 0 is the easiest number to deal with. Then I'm going to pick multiples of 4. So that would be 4, 8, 12, etc. So let's start with 0. Okay, if I multiply m equals 3/4 times 0, that's pretty simple. M is just going to equal 0. Okay, so the next multiple, again, you want to pick multiples of the denominator. This is going to allow me to work with whole numbers versus fractions. And if ever possible, you do want to work with whole numbers. It's easier, and when you're working with MyOpenMath, it may be restricted to only allow you to plot whole numbers. So I'm going to go ahead and try 4. So m is going to equal 3/4 times h, which I'm using a 4. So I'm going to go ahead and put 4 over 1. So I can see that I can cross cancel. So it's just going to be 3 over 1, which is just 3. So let's plot that order pair. 4, 3 goes right there. So the next multiple of 4 is going to be an 8. So I'm going to go ahead and multiply that. M equals 3/4 times m, times h, which I'm making an 8. I'm going to go ahead and put it over 1 so I can cross cancel. So this is going to be a 2, so it's going to be 3 times 2 over 1, which is 6. So we're going to do 8, 6, which is right here. Now, the next one would be the next multiple of 4, which is going to be 12. So m equals 3/4 times 12. I'm going to go ahead and put it over 1. I can cross cancel. 3 times 3 is 9 over 1 is just 9. So we're going to go ahead and do 12, 9. And there you have our graph. So what's great to see is that I do have a linear graph and it goes through the origin, and I expect to see that since my equation is in the form of y equals kx. So in other words, we don't see a constant, which allows us for the graph to go through the origin 0, 0. So here, what is the unit rate? Okay, there's a couple ways to find the unit rate. Typically, we would look in a graph or look in a table. If we're looking for a table, we're looking for 1, k. I can't see it in the table, but I can see it in my graph, kind of. It's not exact, but I would guess that is going to be 7,500 miles per hour. Why? Because it comes from the equation. Remember, it's in the form y equals kx. So what's k? K is a constant proportionality, but when you put all the units together, it is the unit rate as well. So 3/4 is 7,500, which is the same thing. And we just put y over x, so it's miles per hour. Okay, for number 7, they're trying to be tricky. So here, what you would want to do is, I would personally write it as a fraction because it's going to allow me to see what the denominator is, and which will also help me figure out what are some good values to plug in for w to figure out what v is. So for this is 2.5, so I would write 2.5 like this. I would turn that into a improper fraction. 2 times 2 is 4, plus 1 is 5. So I would write this as v equals 5/2 w. These equations are equivalent, just one is expressed as a decimal, one is expressed as a fraction. Now, once again, why did I pick a fraction? Because by picking a fraction, I'm going to be able to pick values that will create whole numbers, because you always want to pick multiples of the denominator. So I would pick 0. Multiples of 2 would be 2, 4, 6. These numbers would allow me to ensure whole numbers as the output. So here we go. If I plug in a 0, we're going to have 2.5 times 0 is obviously 0. Okay, and so now we're going to plug in a 2. But here is where I would definitely use my 5/2. Now, could you use decimals as well? Absolutely. But I like working with fractions so that I can cross cancel and make things a little bit more simple. So I'm going to cross cancel, leaving me with 5. So 0, 2, 4 is next. So we're going to do v equals 5/2 times 4. I can cross cancel, leaving me with 5 times 2 is 10 over 1, which is just 10. So we're going to graph that 4, 10. Now again, the next multiple is going to be 6. So if you forgot, again, we are simply using this equivalence equation so that I can pick multiples of the denominator to ensure I have whole numbers to work with. So v equals 5/2 times 6. I can cross cancel, leaving me with 15. So here we're going to go 6 and all the way up to 15, and there is my graph. Again, I know it's a proportional relationship because 1, it does follow the form y equals kx. It is linear and it goes through the origin. So I know that it's supposed to be a proportional relationship, but it's just good to review those characteristics that we see. Okay, so at this point, what I'd like you to do is go ahead and pause the video and try this one by yourself. Okay, so let's quickly go over this problem to see how well you did. Hopefully, you picked multiples of the denominator, which in this case was a 3. So first, always go with 0. You should have gotten 0, which proves it goes to the origin. Now, that's something that you must understand, that if it's a proportional relationship, that's one guaranteed ordered pair that you will know. It's going to go through the origin. So I'm going to go with 3 next. If you plug in a 3, you'll get c equals 5. So we're going to graph that point. Next, multiple of 3 would be 6. So if you plug in a 6, you're going to get a c value of 10. So graph that ordered pair. And then the other multiple of 3 would be 9. So if you plug in that value, you would get 15. So 9, 15. So here you go. It's the graph to a proportional relationship. Again, we see that it's linear. It goes through the origin. And you would expect that because this follows the form y equals kx. Now, what is the unit rate? Well, here we're talking about cost and we're talking about the number of apples. So here I wouldn't say 5/3 dollars per apple. And how did I get to this number so quickly? Because remember, this is y equals kx. K is a constant of proportionality. Now, the second you add units to it, then it becomes a unit rate. But because since this is money, I wouldn't say 5/3. I would convert it into a decimal to represent it as money, and I would say that it was $1.67 per apple. Well, guess what? That actually concludes the lesson for today. Thank you so much for tuning in, and as always, until next time, bye!